4.4 Graphing Composite Functions. So there's two ways that you can do this. The first way is to combine the functions and make a new equation and then graph that equation. Or you can do it with a table of values. So I'm going to do it with a table of values so we can see that process. So what we're going to do is we're going to choose our x values, and we're going to be really easy. -2, -1, 0, 1, 2. And then we're going to do our inside function first. So we're going to do g of x. So that's 4 minus x squared. And then we will do f of x after, which is x plus 1. So we're going to plug it in and figure out our y first. So we're going to plug a -2 in for x squared, so 4 minus -2 squared, so 4 minus 4, which is 0. So I want you to pause this video and I want you to fill out the remainder of these numbers for this portion of the graph. So you should have got 0, 3, 4, 3, 0. Now what we're going to do is we're going to plug all of those into the second equation. So 0 plus 1 is 1, 3 plus 1 is 4, 4 plus 1 is 5, 3 plus 1 is 4, and 0 plus 1 is 1, and then we will just graph. Oops. Man, I'm not very good at drawing straight lines. Okay, so 0. So we're still going to plot, this is our x value, and now this is our y value. So let's go every 2 lines is worth 1 to spread this out. So we have our first point is going to be at -2 and 1. Let's go every 2 lines. 1, 2, 3, 4, 5. 1, 2, 3. 4, 5. Okay, so -2 and 1 is our first point. Then we have -1 and 4. Then we have 0 and 5. Then we have 1 and 4. And then we have 2 and 1. So we don't graph these points. They just helped us find our coordinates. If you weren't sure on the coordinates, these are the coordinates. So it's the x value from the first column and the y value that we just evaluated. So here's our parabola. We would be able to find an equation for that. To do that, we would plug this into our equation. So let's just do that anyways. So we have 4 minus x squared plus 1. So we have -x squared plus 4 plus 1, so we have -x squared plus 5. And this makes sense because it has a vertex of 0 and 5 and it's opening down. So again, you could have done this and then graphed -x squared plus 5 because that is also well within your abilities. So our domain is x is an element of the real numbers. Our range is y is less than or equal to 5. So you can do it either way. This way would definitely be faster because you can probably graph that parabola quite quickly. But just know that a table of values will always work. So I am okay with either of those things. I'm going to do it with both ways for the video. So, okay, next one. So we're going to do f of x. So we'll do the same thing, -2, -1, 0, 1, 2. And then we're going to do f of x, which was that x plus 1. And then we're going to do it again. So we're going to plug -2 in, and it becomes -2 plus 1, which is -1. And then we're going to plug it in again to get 0. So I want you to pause this, and I want you to fill in the rest of this chart. So you should have got 0, 1, 2, 3, and 1, 2, 3, 4. So to graph this, you should be able to tell that this is a line. Oh my gosh, straight lines are hard. So we have our points that we're plotting are -2 and 0, -1 and 1, 0 and 2, 1 and 3, and 2 and 4. So same as last one, we'll go up by 2's. On both axes. Might as well spread her out. So we have negative 2 and 0, negative 1 and 1, 0 and 2, 1 and 3, 2 and 4. So it is a straight line. And again, you probably could have graphed this on your own, because if I plug an x plus 1 into the other equation, I would get x plus 2. So it's a y-intercept of 2 with a rise and a run of 1 over 1, which is exactly what we have. So our domain, it's a line, so element of the real numbers for both the domain and the range. Alright, so that's how we graph composite functions. Let's do some that are a little bit more difficult, maybe. So we have 2x minus 1 and x squared minus 2. So we'll start with a table of values. Oops. So we'll go negative 2, negative 1, 0, 1, 2 again. And we're going to do f of x first, which is our inside function, so 2x minus 1. And then we're going to do g of x next, which is squaring it and subtracting 2. So negative 2 times 4 is negative 4, minus 1 is negative 5. And pause the video and fill out this whole column. So you should have got negative 5, negative 3, negative 1, 1, and 3. I'm also going to have you add in 0.5 in here, just because it's going to make it easier when we do our next portion. So if I plug a 0.5 in, I get 0. Okay, now we're going to plug all of these values into g of x. So negative 5 squared is 25, subtract 2 is 23. Okay, pause the video and fill the rest of this in. So we get 7, negative 1, negative 1, and 7. And the reason I wanted 0.5 is it's going to be that vertex between 0 and 1, and you should have got negative 2. So we're going to graph this. So we'll go up by 2's on the x-axis, but we'll go up by 1's on the y-axis. So we're going to be plotting, well, not this point because it's way too big, but we can plot negative 1 and 7, negative 1, or 0, and negative 1, 1 and negative 1, 3 and 7, and 0.5 and negative 2. So we have negative 1 and 7 right there. We have 0 and negative 1, 0.5 and negative 2, 1 and negative 1, and 3 and 7. Oops. Or 2, this should be 2, that makes no sense. 2 and 7, there we go. So our graph would look like this. So again, we probably could have figured this out on our own. So we're going to plug in f of x into g of x. So we have 2x minus 1 squared minus 2, which is the same as 2x minus 1 times 2x minus 1, subtract 2, which is 4x squared minus 2x, so minus 4x, plus 1 minus 2. So we have 4x squared minus 4x minus 1. So that is the equation for it, which you could have graphed, but that's a lot of work to go from there. You could factor, find the vertex. So for this one, the table of values is way easier. So my domain is that it's an element of the real numbers. My range is that it needs to be greater than the vertex at negative 2. Okay, next one. Okay, and this is the most complicated one because we're doing g of x, which means we're combining a parabola with a parabola. So what that means is we're going to have an x to the power of 4. So we're going to be plotting a quartic here. So let's do the equation first. So we're going to plug in x squared minus 4 squared minus 4. So we're going to have x squared minus 4 times x squared minus 4 minus 4. So we have x squared minus 4x, so minus 8x squared. I did not put a 4. I said it. And then we're going to have plus 16 minus 4, so it's x squared minus 8x squared. Okay, okay, let's try that again. I'm sorry, I can't go back and fix it. I have to just keep going because like we're already 11 minutes into this video. Okay, let's try it again with 2's. So we have x to the power of, or it's the same as x squared minus 2 times x squared minus 2 minus 2. So you have x to the power of 4 minus 2x squared minus 2x squared, so minus 4x squared plus 4 subtract 2. So our equation is x to the power of 4 minus 4x squared plus 2. So you might not know how to graph that, and that's totally fine. It's a lot of work. It's back from the last unit. You'd have to factor, find the intercepts, all that jazz. So the table of values is way and significantly easier here, so let's do that. So we have negative 2 squared makes it 4, subtract 2 makes it 2. Okay, pause this video and fill out that entire column. So you should have got 2, negative 1, negative 2, negative 1, and then 2. Now we're going to plug it back into itself. So 2 squared is 4, subtract 2 is 2. That point didn't change. Pause the video, and I want you to find the rest of these points. So you should have got negative 1, then you should have got positive 2. So negative 2 squared is 4, subtract 2 is 2. Then you should have got negative 1, and then you should have got positive 2 again. So this graph should look like at negative 2 it hits positive 2. At negative 1 it hits negative 1. Then it pops back up at 0 and hits 2. Then at 1 it hits negative 1 again. And then at 2 it hits 2. So my graph would look like this. So our domain for this function is x is an element of the real numbers, and our range is y has to be greater than that those lowest points. Those are kind of like our intercepts, and they're negative 1. Alright, and that's how we would graph that. Good work. Last example, for each function, determine possible functions for f and g so that f times g of x is whatever it tells you. Okay, so we're going to work backwards. So we want, for the first one, I'm going to say g of x makes it x squared. It squares our number. And then f of x is going to make it into the reciprocal. So it's going to be 1 over x. So if I do f of g of x, the first thing it's going to do is going to make it an x squared. So now we're going to evaluate f of x squared, and then it makes it a reciprocal, so 1 over x squared. So there is an example of how you could determine those two functions. So g of x squares it, f of x makes it a reciprocal. Okay, the next one, we're going to say g of x is going to times it by 3, square it, and add 1. And then f of x is going to take the number and raise it to the power of 4. Next one, g of x is it's going to take your number and subtract the 2. F of x is going to raise your answer to the power of 3. And the last one, g of x is going to make 3 plus your number, and then f of x is going to take the square root of your number. So there are all your functions, and when you plug them in, you should end up with your last term. All right, that's the end. Just kidding, there's a part 2. Until next time, folks.